Okay. So I don't know who yesterday. Yes, I actually do know. Someone wanted technical talks, so we're going to have a somehow technical talk again. So Angel from Talos, Angel Villegas, you have the floor. Thank you.
Thank you. All right. So as he said, I'm from Cisco Talos, and I do a lot of in-depth malware reverse engineering. So my day-to-day is basically get a sample, analyze it. Maybe I create some tools or I create some scripts to help automate decryption of things, the obfuscation, maybe doing some memory forensics and stuff like that. It's kind of varied from time to time, but basically it's okay. Basically, it's the same kind of process over and over again. Get a sample, look at it, and that sample may take maybe a day to look at in order to get some very specific information from, or maybe we're looking at the sample in order to really understand exactly what it does, try to find and enumerate all the C2 commands and their corresponding actions. Or it might be to try to figure out what the DGA is, program that up so that way we can then blacklist IPs for this given botnet or given malware family. But over time, I might look at a malware sample. Maybe a couple months goes by. Maybe next week I have a new sample from that malware family. Maybe it's updated version. Maybe it's an older one that's still in circulation. The fact is that a lot of times I'll end up looking at the same kind of functions over and over again. Now, I do pretty well with going through binary and analyzing and understanding what it does. However, I don't do really well with understanding, okay, this function I saw 5 weeks ago, or maybe a year ago, or something very similar to it. And it's hard to kind of preserve my previous analysis and apply it to future works. In addition, it becomes even more difficult when it comes to working in a team environment. There have been several things that have come out in the past to kind of help with coordination, kind of think of Google Docs, but with IDA or something similar. And that's very helpful when you're working on a given binary or a given sample or a given series of samples in a group environment. However, a lot of times there's a disconnect. You aren't usually working on the same samples at the same time, at least in my job. So in order to help overcome this, created there's a little bit of delay. Create a tool to help automate this process. I get used to using flirt signatures, which IDA provides, and I'm in IDA quite a bit, but we have other analysts that are using mostly Radar or other different analytical frameworks. The idea behind FIRST was to create a way to help preserve the analysis done by a given reverser. So that way we can then apply that to new reversing efforts and save time, or at the very least, start narrowing down and filtering out what's important or what's not. Now, this could be done as far as maybe we're looking for a DGA, and this malware family usually uses the same function in order to come up with the domains. However, they use a different seed for each one. And so maybe if we need to find that seed, it could be very easy to figure out, okay, this is the function, and now let's backtrace from there in order to get the seed acquired. So today I'm going to talk about our IDA Pro integration that's associated with FIRST. As I said before, we've got different analytical frameworks, and we're working to try to integrate FIRST into other places so that way people have a flexibility to get information no matter what environment they're working in. But as of right now, we've released an IDA Pro plugin, which will allow users to do very basic things to interact with our FIRST server. Okay. I don't know why this is not syncing up correctly. All right. So installation. This framework was created with in mind to keep and preserve annotations, so that way others can leverage them in their own research. In addition to that, we want to make it as easy as possible to integrate into your workflow. There's been some solutions out there that are pretty nice, pretty easy, pretty convenient to use. However, they may not be very convenient or have ease in order to integrate into the workflow that we use as reversers. First, the plugin aspect of it can be installed pretty simply by either manually installing it yourself. Only requirement for it is the request module. And if you're working in an environment that uses cross authentication, then that can also be included. And then just simply copying all the plugin files to the IDA-Pro folder. If that's something you don't want to do, you can also use the pip package associated with first, IDA's plugin, and then run a post-installation script in order to copy over all the files to your IDA plugin directory. Once installed, when you initially open up IDA-Pro, you'll be presented with a welcome screen. That welcome screen will allow you to connect to whichever first server you prefer. First being an open source framework, we've created and are hosting a public server. You can see the server details here on the slide, first-plugin.us. If you want to use a public server, enter those details in and you can be connected to it. However, let's say you're working in an environment where you don't have internet connectivity, or maybe you're working on a closed network, or maybe you just have other intellectual property you want to prevent from being out there and open to the public. If that's the case, you could easily stand up your own first server in a VM or on a dedicated server in your own environment and start using that. In order to make it more streamlined and easy for people to actually start getting information from First and also adding information to First, we've decided to leverage the right-click menu. So most of the time when you're reverse engineering, you're in the IDA view, whether that's graph mode or the text line mode. Via using the right-click menu, you can then access most of the essential operations associated with First. Whether that's to check a single function to see if there is any annotations or metadata associated with that function in First, or to check all of them at once. Another set of operations is to add your own annotations to First. When I say annotations, I mean the function name, function prototype, and repeatable comment associated with the function. Now, granted that those kind of things will change a little bit depending on what analytical framework you're using. However, that's the core information that you'll be gaining or adding to the First database. In addition, let's say you are working in a team environment. You have a couple people reversing samples, maybe an older version of a malware family, you're reversing a newer one. There might be some overflow. There might be also some overlap between the two. And if that is the case, maybe you want to keep up to the latest annotations created by your teammates. Additionally, we have the option where you can view metadata history. So I might come in one day and look at a function. I might just go really quickly through it and say, okay, I'm not sure exactly what this does, but I do know I've looked at it, so I might put a small little annotation associated with the name or maybe a comment that says I've looked at this function. So next time I see it, I know, okay, maybe this is an essential function, maybe it's important, used a lot, or maybe only used once. If that's the case and I upload my annotations to First, it's going to keep a log of the different changes I've made to it. This is also very helpful to, let's say, office mate comes in, he decides, okay, I'm going to work on something. He updates it. However, the function that he's looking for is no longer there. Maybe the name has changed, and this will allow ways to kind of trace back and see and understand how those annotations have changed over time. Creating annotations, really helpful. Adding them to First is going to help both yourself and others. But I know people generally kind of test things out a little bit to begin with. So in doing this, in our testing, I've opened a sample of Zeus, prefaced all of the function names with the Zeus underscore and hash associated with that sample, and upload all those to First. Open another sample of Zeus, checked all the functions associated with it, with whatever annotations were in First, and got tons of hits. Now, the names I provided were not very helpful at all because Zeus underscore hash underscore sub and whatever address it's located at is not going to provide very insightful information. And due to that, we allow people to also manage their annotations that they add to first. Now that I've quickly talked about the plugin, I'm going to go over briefly the server component of it, so that way people can kind of understand what it's built on and maybe how they can also go through and extend it. So first is built completely with Python. It leverages Django and also MongoDB. In our beta version, which is currently out, and our public server that's hosting it, we are using Google's OAuth. In order for us to not have to reinvent the wheel, manage and contain user names, user information. I know that a lot of people may have questions when it comes to signing in with other OAuth kind of portals or clients. First only uses that in order for it to log in, to assign you an API key, and it only retains your email address and a name to present to you when you log into the first server. So no other information. It's not posting on Google+. It's not trying to share any other information out there. In the beta version right now, we also have a couple of engines associated with First. Now, these are very basic. However, First was created to be modular and to allow people to expand upon it and add their own engines. I'll talk a little bit more about that in just a little. So here is a very basic diagram. We got the first server, which exposes the REST API to the plugin. And we are also creating APIs and ABIs that work with this REST API. So that way you can also integrate it into, let's say, your own workflow that may not leverage any of the standardized tools that are out there. Inside of the framework, we have a database manager. First leverages MongoDB. It was kind of a newer database. Decided, hey, this is kind of flexible. We'll run with that. We'll give it a go. It allowed us to kind of build things out quickly. However, we do realize that not everyone uses MongoDB. And maybe you already have a way of determining one similar function to another similar function, but you use a different data source, or you use maybe a different architecture backend. If that is the case, First allows you to create a database module, which you can then provide a layer of abstraction to interact with whatever data source you require. That database object can then be leveraged in your engine. And in order to help manage engines, we've got an engine manager. With the beta version currently, we've got 3 different engines. One is exact match, just taking the opcodes associated with a function, hashing them. Very basic, very simple. Not really much there. However, pretty good indicator if something is one-to-one match. Next, we have a mnemonic hashing engine. What this engine does is takes the opcodes, converts it back to disassembly, does away with all of the operands associated with the instruction, and hashes the mnemonics. This one's a little more flexible as far as how useful it is. For very short, small functions, it may not be that useful, especially if they're wrapper functions or do something to call right into another function. However, it can be an indicator of something maybe that's been seen before. And especially with larger functions, this kind of hashing does provide a little bit more of a fuzzy ability to match. And finally, we've got the basic masking engine. What this does, much like the mnemonic hashing, is it takes the opcodes, converts it back to disassembly, and instead of just doing one-to-one matching or the throwing away of all the operands with the mnemonic hashing engine, it will go through and mask off certain things, like offsets to calls. It will it will mask off, let's say, offsets from stack pointers, so ESP and EBP. This will allow for if a newer version of a function comes out, and let's say they change the order of arguments, or maybe when they compile it again, the order of local variables are changed up. This will help to match for that. In the future, we plan on also incorporating a locality-sensitive hashing, maybe also different technologies, to do a quick matchup to see if one function is similar to another. A framework like this is very helpful and very useful, but actually it's only as good as the data associated with it. And for that reason, we've gone through and taken several open source projects out there and have compiled them with various different compiler flags and optimizations. thereby getting symbolic information for it and opening those compiled binaries in IDA, matching it with the symbols, and uploading that information to first. This helps us because quite often when we're looking at botnets or different malware families, we'll see that there are a lot of statically compiled OpenSSL functions or many other things out there. And even source code that's leaked, you'll find remnants of that in different malware samples. Okay, so with that, I'm going to go into a small demo. Okay, with this sample, this is actually a sample that our office recently got via one of our hunting teams. They had a little bit of an idea. They said, we got this from area A. We believe it to be this malware family. However, we're not sure. There's not really a lot of information about it. Can you please go in and understand what it does and verify if it is this malware family or not? Opening up an IDA. Sorry, I'm gonna have to try to go back and forth between the mic and demoing this. That's very nice. All right. So I just opened an IDA. I've already configured first, so that way it has a local server. Looking through the function list, there's a bunch of functions. All right, we've got some stuff that has already been identified via IDA and or flirt signatures, but nothing else besides that. This is usually where most of my research starts off, looking at seeing hundreds of functions, but yet nothing really to get me started. Everyone has different methodologies for reversing samples. You might end up looking through the imports, maybe exports, whatnot. However, with first, this will allow you to check something from the beginning and then maybe start doing your research from there. So via the right-click menu, as I showed during the slides, we've got several different operations we can perform. I'm going to just blindly query all the functions in this sample. First, chunks up the search results and the search queries. So instead of us just searching blindly for all of them at once, we start searching for 20-bit chunks, 20 functions at a time. This will allow you to both get information, start kind of filtering through it, and also to see that something is going on and working as time goes on. So I'll just point out a couple aspects to this window. We'll have down here, still searching first. We see the number of matches currently out of the total number. We see that it just finished searching. Let's say you've gone through, or maybe you received an IDB from someone. Maybe some things are already listed or already annotated. If that is the case, you can kind of take away anything that's not a sub underscore function. And if you want to, you can just blindly select highest ranked. In addition, there will be a couple of different colors used. You'll have a certain color for anything that you've currently applied to your IDB. So let's say you've applied something, maybe via the check single function, and then you do a query for all functions in your IDB. And then anything that you select will also be a different color. We're using a tree view kind of system here, and we'll see that the first thing that's shown is the actual address in your local IDB. So this is the first row corresponds to information in your IDB, your view, and everything underneath it is a match as associated in first. Now we see here that there is 100% matching. However, this percentage is determined by the engine itself. So let's say someone goes through, creates a test engine. However, that engine may not be the greatest thing, or maybe they didn't actually go through creating some kind of similarity or threshold percentage. They could very well say, oh, everything's 100%. in which case you may indeed want to look at what engines matched on that given metadata match. So here we see that we actually have matches from all three engines that are in our system: the basic masking, the mnemonic hashing, and the exact match. What first does is it takes all of the metadata results and combines them into one and actually sets the threshold or the similarity matching to the highest percentage available. If we want to, we can right-click, go to the function in our IDB to then decide, okay, does this metadata make sense? Is it helpful? Or is this a very small wrapper function that actually doesn't apply to that? Or we can select View History, in which case we can see the little bit of history that's associated with the function. Let's look at something a little more interesting. We've got 1 match, 2, 4, 3. Let's just keep scrolling down. All right, this one has 13. All right, now that we expanded that, we see that there are several different matches. And when we look at the engine associated with it, it was only matched by the mnemonic hashing engine. Expanding to see what the repeatable comment is, we see that this is coming from a leak source with the Pony malware. The fact that we have the same kind of naming convention and just kind of quickly spot checking, we see that only mnemonic hashing engine matches for it. This tells me this might be a very basic function. Maybe it's a function that passes another argument to the main function that does the actual grabbing of fling or VS design. So let me do go to function. In this function, I see, okay, that's exactly what's happening. I have offsets to strings. If you guys are not familiar with that string, a quick Google search will show you that's one of the developers for WinSCP. So looking here, I see that that's actually a better choice than anything else that's on there. Now I could, if I wanted to, go through all 178 matches and try to determine what's what and if it's helpful, or I can select the highest matches. In this case, we see that the grab fling is actually selected because right now it has the highest similarity matching and it also has a higher rank. The ranking is created by the number of users and unique samples associated with that user. So if I was to apply it to a binary, it would get 1 rank higher. If I open that same binary again and I try to apply it, it's not going to continue escalating that rank, it's going to keep it the same. So another analyst goes through and they add it to their binary, the rank is going to go up again in order to try to filter out maybe a more useful or useless metadata annotations associated with it. Here is another one. You see this one has 26 matches, and a lot of them follow the same kind of naming convention, grabbing information from various different programs, it seems. And again, if I go to that function, I see that this one actually corresponds to the core FTP. So I might go through and say, okay, actually this doesn't make sense for the website publisher. I should be selecting the core FTP one. And I can continue going through this, filtering through and all that, but I'm just gonna go with the highest selected ones and that randomly corrected one and hit apply. First, we'll go through and we'll start applying the metadata to the functions that you have selected results for. Every once in a while, especially when you do a blind application of the highest ranked ones, you might see that the same metadata name is trying to be applied to another function. This is the same thing that would happen if in IDA you try to open up a function, name it function1, open up another function, say it's function1 also. IDA will try to tell you, sorry, this name is already being used. Would you like to add a suffix to it? With first, due to its automated fashion, you're just going to get this kind of information dialog box. Click OK. This is going to happen several times. We did have 173 matches. So I just selected for that not to be shown again. Now, just because we decide to skip those and they're not going to have actually those names applied to them, doesn't mean that we've lost that information. In the output window, you'll have a listing of all functions that you were unable to label. So this you'll be able to then go through, double click on it, trace through, say, okay, well, this is something that should be labeled. We see that the repeatable comment was still added to it, and if there was a prototype associated with it, that would be applied too. I could then, if I want to, right-click, do check first for a single function, and then apply the correct metadata associated with this, now that I'm looking at it. All right, now I just want to show a little bit. As I talked about in the slides, you can manage your annotations. So because this is a demo account, I create a couple of things. We see, okay, this may be helpful, it may not be. I can go through and look at the history, how I've changed the annotations for that given function over time. Also, if I want to, well, real quickly, just to help show this, now when we're looking at our function list here, we see that there's still sub__ functions. However, we see that there is a lot of additional information here. Whether or not it's really true or not kind of comes to a different matter, since we just blindly applied stuff, so things could have matched on mnemonic hashing or basic masking, in which case it could be correct. It very well could be that it's a very small wrapper function. But if we look at this, we see, okay, here's an RC4 setup function. Here's an RC4 crypt function. If our task at looking at this sample was to figure out what encryption was being used, or maybe to determine what RC4 key was being used, this could very well help us save a lot of time versus trying to search around the sample manually. If I double click on that, look at this function, we see, okay, here's a loop. This looks like the initialization, so it looks like it very well could be correct. So that would help us then go back and start looking at different functions to understand, okay, what is the important information I'm looking for? What do I need to look at? Again, just going through, we can see tons of different functions with actual data associated with it. However, we may not want to go through the function name window. Instead, it could be easier to go to the first plugin window and select the currently applied. From here, we can go through and see all annotations that have been applied from first to our local IDB. We can right-click, view its history if we wanted to, and go to the function. Since we have a little bit of time, I will just quickly show a couple of the other dialog windows. So when it comes time for you to add your own annotations to first, if you choose to do so, your arm must be getting really tired, right? It might be the case where you might want to add only one function at a time, in which case this dialog window will show the metadata associated with the function you are getting ready to add to first. Or you can select to add multiple functions to first. This will go through and list out every single function in the IDB and the annotations associated with it. With this one, you have the option to filter out sub__ functions. Since you're wanting to add information at first, things that have the default name that IDA provides may not be the most helpful thing to add. Also, we have a little bit of a different color scheme associated with it. Let's say you've added some annotations to first. When you add something, when you change something, the function will be highlighted in a different color to show that it should be added to first, or at least there is a change since the last time it's been added to first. It has been unchanged, whether that's because it's you've applied annotations from first, you will see this kind of grayed color. Default value for things that IDA has already defined will be white, and anything that you select will be blue, and that will be uploaded to first. Once metadata is applied to a function, you will also have another option to view the metadata history from that function itself. Now, I've gone through and blindly applied a bunch of stuff. If I was to take this and say, actually, let me quickly check first. Okay, so this was 100% accuracy. But let's say it was 75% because maybe it was matched via mnemonic hashing or some other engine that's out there. If that is the case, I may very well want to re-add it to first, so that way now we have another sample pool to say, okay, this is an RC4 implementation. And the next person that might see it, they'll see 100% matching, and it'll add more confidence to that. If I was to go through and say that this has been verified, now if I was to add this function to first, if I check it now, real quick, note here in the output window, it says that one function was added to first. So if we were to add multiple ones at once, that would also be displayed there. Now we see that there are actually two results for it. The reason for that is, me being a different user, if I am to alter someone else's annotations that I've applied, that doesn't actually go through and alter the annotations that they added to first. It actually creates a new instance where it's now my own annotation. So let's say someone named this RC4 something. I looked at it and said, oh, this is actually the setup for RC4, in which case people might look at it and say, okay, setup for RC4 is more useful and helpful than RC4 something. Thank you. Okay, so now that I've gone very quickly through a demo, I just want to point out a couple of resources for the project. As I said, we have a public server up and running, hosting. Right now, I think we're up to about 60 users, and we've got about 180,000, close to that number, functions that have been added with metadata associated with it. As I said, some of those come from the data that we preloaded into first. Other ones are coming from active contributions from the community. First was created to be open source and also to be modular, so people could go through and extend it in their own way. So we've got several documents out there that help you to understand the composition of first, how it was created, and also if you want to both script it in IDA or if you want to leverage different components. So if you want to create your own engine or your own database module, you can very well do so. With that, I want to open it up to see if there are any questions.
Okay, questions? Yeah.
Hi. Hi, thanks. I came in late, so sorry if my question doesn't make any sense. What is the engine that you use in the backend? Like, what kind of problem with IDA is that IDA has its own way to see like functions and stuff. If you do like something with Radare or with like Anger or something else, you're gonna have different sort of functions. So when you try to reconcile that down to IDA, you miss half of the stuff. So what kind of engine that you guys are actually using in order to make it at scale? Unless you're like just packing IDA into some servers and just run it again and again, right?
Okay, so I will answer your question in addition to provide a little bit additional information surrounding it. So you talked about information that's included. First is done by user interaction. So nothing is done kind of automatically. So if you install first and you open up IDA, it's not starting to send up information to the first server. It's only done when you actually try to do an operation. When you try to check for information, all it's sending up is the opcodes associated with the function and information about the sample itself. So the MD5 of it, things like that. First, we'll then go through, and its engines will just look at the architecture and the opcodes, and the engines have the ability to use that information or not. So let's say you create a engine that looks for maybe cryptological constants. And these are some ideas that we have thrown around that currently are not engines, but will be hopefully in the near future. So if you're looking for cryptological constants, then you could very well just look at the opcodes associated with it and totally disregard the architecture associated with those opcodes. Other things might be, what we currently have is an exact matching, which is just taking the hash of the opcodes sent to the first server, and it also uses the architecture associated with it. So if you have an exact match for Intel and for ARM, well, clearly those might mean completely different things, especially when disassembled. And for that case, the engine has the capability of determining whether to use the architecture or not. The other engine we have is the exact match mnemonic hashing, where we just take the mnemonics, hash those. Again, another very quick lookup. It's better for a little bit of a fuzzy matching when it comes to bigger functions, not very useful for smaller functions. And then finally, we have currently the basic masking, which I stated earlier includes the disassembly for the function, but it masks out different things. So constants that seem to be global addresses in the virtual address space of the sample, jumps, the relative offsets for them, any offset for stack pointers and things like that. We do have a couple of ideas for several other function or engines in the future that can help to kind of correlate and provide a little bit better fuzzy matching. One using a locality sensitive hashing or LSH. Other ones that might be more prone towards certain malware families. So some things have basically no-op instructions, in which case if we can abstract those no-op instructions out and basically normalize into the actual core of the function, we might have better chance of matching stuff that's already been seen. But people can openly develop new engines, and that's what we are hoping will happen, because from an academic point of view, people are looking at how can we see if one function is similar to another. Some of those research areas are very time sensitive, where they can either operate in just a couple moments. Other ones are very long in their comparison of one function to another. So first was kind of created to get that lower hanging fruit and quickly get it for the end user.
Okay, there's time for a tiny question.
Hi, thanks for the talk. Rafael from Kudelski Security. I was wondering, will it be possible to configure the plugin to query multiple servers at the same time?
Great question. Currently, that is not in the plugin. However, the plugin itself is open source also, so it can be expanded to do so. And the REST API associated with a given server is open and available. The only thing is that first associates, there's no login once you actually start using the plugin. It has an API key that you leverage. So with multiple servers, you will need to then just handle and manage multiple API keys that are correctly associated with that server. But there's no reason why in the future we can't expand and add that capability.
Okay, thank you.
Thank you.